Good afternoon. Good afternoon, everyone, and welcome to today's webinar. We're so excited to see everyone here. Meanwhile, I would like us to interact a little bit. So this place doesn't look like a dead end. So please let me know your name and the name of the school you are representing, or the school where you work, or the school where you lead. Okay, so I'm going to be calling out I'm going to be reading through the chat. Okay, please do well to drop in your name and the school where you're joining from in the chat. I'm going to be reading it out while we wait for others to join. Okay, please confirm that you can hear me, Paul. So much, Engineer John Ejiro. Engineer John Ejiro is from Teach Girls Tech Foundation. Is from Teach Girls Tech Foundation. Thank you so much. We've done well to wait for a while. And so we're going to kickstart in earnest so we can close and finish round this up on time as well. So who are we? First off, let me welcome once again to this webinar. And I'm going to let us know at the end of the webinar what we'll be learning. So we have a lineup of agendas. So I'm going to start with who we are. So we are a team from Generative CAD Services. So Generative CAD Services is a leading engineering and digital manufacturing solutions provider, or what we call company. Okay, but more importantly, we are deeply committed to helping Nigerian schools bring practical STEM learning into classrooms. This means that we work with schools, we work with STEM clubs, we work with robotic teams to set up modern 3D printing and innovation labs that help students build creativity, help them with problem-solving skills, and even going out there to solving real-world technical issues with confidence. So part of what sets us apart is that we don't just teach 3D design and 3D printing, or encourage schools or hold schools to start up or advance their STEM with 3D design and 3D printing. We also provide a complete, what I would call 360 solution. So what we do, we properly onboard teachers, we support with curriculum, as well as we offer after sales assistance. So it's like a 360 solution, not just a one-off thing, okay? And we are able to do this because of the partnerships we have with our global brands. We have partnerships with FlashForge, which is why it's only FlashForge 3D printers that we give out currently. And we also in partnership with Autodesk as well. And so we have worked with different schools, and just basically, simply put it, that we help schools deliver both practical, we help schools deliver both in practical and sustainable and impactful way. All right. So thank you so much. I hope by now you understand who we are. So we are Generative CAD Services, and that's the name of the company. And that's a little bit about us. Okay, thank you so much for joining once again. A lot of people have joined since the last time we actually introduced ourselves, but let's move on. Okay, we have a webinar rules of engagement. So this is basically how you can make the most out of this webinar. All right. So first off, our microphones are already muted. I think that came from the technical aspect. But if you want to speak, you can unmute it or indicate to be unmuted, and you definitely be unmuted. Okay. If you have any questions at any point in time, feel free to drop it in the chat. If you look up in the horizontal, I don't know if you're using a PC or using a phone, but just look somewhere on your screen. You will see Q&A. QA, that's actually what you see. So use that button to ask your questions, or simply just put in the chat. We will read it regardless. Okay. And if you want to speak, please use the raise hand feature, and someone from our team is going to unmute you and you're going to speak. Okay. We kind of muted it to avoid background noises or people who might forget to mute themselves. So everybody's camera is off right now and it's completely optional. Do whatever you want to do. You can choose to turn it on or turn it off. Depends on whatever is your choice, okay? And finally, if you have any technical issues, sometimes you stop hearing or sometimes you stop seeing, just leave and come back. That's how this works, okay? And if it's something that you've left and you're back and the problem is still not solved, just type tech help in the chat, and somebody is going to reply your chat and would ask you follow-up questions to exactly know what is happening with your technical back end of things. Okay, so please, we urge you to stay with us to the end of this webinar because we'll be sharing some important announcement at the end, especially the exclusive donation part that is meant for attendees. And we are going to be taking, we've spent 13 minutes already. We hope to end by 4, but give or take on or plus or minus 4 p.m. will be over. If we take more time, we'll be maximum 10 minutes after 4. So please stay with us to the end so that we can make an interesting, have an interesting conversation and webinar with everyone. Stop sharing my screen at this point, and I'm going to dive deep into the crux of the webinar right now. My name is Linda. I'm the head of marketing and partnerships here with Generative Car Services. I'm going to be handling this webinar with my other colleagues. You've heard me speak to Paul in the beginning. Yes, Paul will be taking over this webinar at some point. And we also have Chukwemeka. Chukwemeka will be assisting us with the live demo presentations, and when he'll be using the 3D printers to walk us through a live demo. So 3 of us are working together to make this experience worthwhile for everybody. Okay, it's important for me to acknowledge my team there. So I'm going to be sharing my screen right now to something that is very important that actually made us to do what we are doing, which is the future of learning. And while my device tries to show screen, while I try to show my screen, because currently it seems like the network is a little bit lagging behind. But what I'll be talking about is what I call the future of learning, which is what we are trying to, the problem that we are trying to solve. Just give me a moment. I'm just trying so hard to navigate things here. Just give me a moment to share the appropriate screen. Thank you so much. I believe you can see my screen. Paul, please confirm you can see my screen.
Yes, Ms. Linda, I can see your screen.
Thank you so much. Thank you so much for confirming. So when it comes to the future of learning, obviously we have seen technological advancements advance, and we've seen a lot of learning go beyond classrooms, go beyond textbooks, go beyond just black or whiteboards, as the case may be, go beyond interactions like online classes, where we now have students immerse themselves deeply with what they've been taught. Okay, we see our counterparts in China. Most of the things, let me just digress a little bit. Most of the things that we buy off some of the popular websites are made by students in these countries. They're not even made by established companies. So, but that is the way that they get to actually practicalize what they've been taught in class. But when it comes down to Africa, and especially in Nigeria, we have a lot of challenges mitigating us to come up to that point where our international counterparts or the global standard is, where the global standard is at the moment. And so we at Generative CAD, we see these problems. We acknowledge the fact they are there, and we acknowledge the fact that there are a lot of things mitigating us from solving these challenges. So challenges such as skill gaps, challenges such as costs, challenges such as curriculum integration. Okay. And so we thought about it and we felt like it's important for us to have schools or educational institutions, I mean, people targeting people 16 years and below, or maybe 18 years and below, or however, but let me just say between below to SS3, right? Just before they enter university. So let's look at these people. They have minimal, let's have them leverage on what we have, the partnerships we have, the skill set of our team members. Let's have them leverage on it to be able to close this skill gap and, match up with the future of learning. Okay, so that is actually what informed our decision in last year to begin this portal with empowering institutions, education institutions with advancements in robotics, but particularly robotics and STEM, but particularly with 3D design and 3D printing. Okay, so I'm going to call on Paul right now to go on and let us know more about how exactly 3D design and 3D printing can help these educational institutions over here close up this gap in the learning or the learning standard in the country. Paul, are you there?
Yes, thank you, Miss Linda. Good afternoon, everyone. My name is Paulo Kandu, and I'm a product design engineer at Generative Cloud Services. Please give me a moment to share my screen. Okay, that's wonderful. So, as Miss Linda was saying, schools are moving past theory, moving past textbooks, moving past tutorials. There's a growing focus on getting students to actually apply what they have been taught to solve problems. That's where things like your STEM initiatives, your STEM clubs, your robotic clubs, your robotic labs come in. And I know some of you here already have this set up at your schools or already are heading these initiatives and are seeing real progress. And that's wonderful. But to make these programs even more successful, we should look at integrating design thinking into the mix. Now, what exactly is design thinking? I would say it's a process of orienting or positioning your mind, or let's say in this case, the minds of your students, to solve problems based on the knowledge they already have. For example, let's say in your STEM club, um, you've taught your students business how to measure and join materials to build things, simple things like a simple box. Like that's the tutorial. Maybe you went through it with them, following a set of instructions. That's a tutorial. The design thinking happens when you ask them to design or to create something out of what you've taught them before. So now they're not following any set of instructions. They are trying to solve the problem on their own. And that's where design thinking happens. For example, now let's say you tell them, okay, I want you guys to design a cable holder to organize these messy cables around our desk. Now, it's not a step-by-step tutorial, so they have to think about the problem. Okay, how thick are the cables? What do we need to do to arrange the cables well so that they don't bend, they don't twist? That's where design thinking starts. So based on this, they design, they test what they've designed, and true, there's no endeavor without a bit of failure. So they might fail, but the fact that they can rebuild on that failure to move forward and incorporate it in what they are building, that is design thinking. It forces them to use critical problem solving skills. So, for example, now they might even need to find, let's say, a shape now or an object that they can't even, let's say they can't find it on the market. It's not something you can see online. And that's where 3D design and 3D printing comes in. So for those of us now that are already acquainted with 3D printing or at least 3D design, um, I think you guys understand the concept. But for those of us who aren't familiar with tech, or the terms rather, 3D design is basically accomplished. That's transforming ideas into um, reality. But 3D design is accomplished with the use of a tool called a 3D design software, right? So it helps turn those ideas, those concepts you have, and turns those ideas into a digital model within that software. And 3D printing converts that model into a physical reality. So it's a whole process, and it starts with the tools in the beginning, which we call the 3D design software, and it ends with the machine, which we know as 3D printer. So 3D printing is a lot like normal paper printing, but instead of using ink, these materials like plastic or metal to create tangible objects. So unlike normal printing, which is flat, you can't interact it beyond just looking at the page. 3D printing has depth, that's width, that's height, right? So that's what separates 3D printing from normal printing. Yes, it's called printing, but it's a far different thing from um, normal 2D printing, even though it does have a basis in the same uh, device or the same technology. So the most common technology for 3D printing, right, is fused deposition modeling, which is what flash roll 3D printers use. And most flash roll 3D printers or the 3D printers we offer use. So it essentially uses melted plastic deposited in layers to build the objects from the bottom up. So you can see in the video, this is the extruder of the 3D printer. It's building something on the build plates. It's layering plastic slowly. The video is a bit sped up so that you can see the full process, but it layers it slowly until it forms a full object, like you see now. So that's basically what 3D printing, or FDM in this case, is. Now the 3D printing process goes like this. You go from idea, the idea you have in your mind, to design, right? Now you make the 3D objects digitally. And this is done, like I said, with 3D design software like Tinkercad, which is what I'm using for the demo today. It's offered by Autodesk, and we are partners with Autodesk. You can also use Fusion, Autodesk Fusion, to create your 3D designs, although that's a bit more advanced. But for today's demo, we're going to be using Tinkercad. So once you've prepared the model in the 3D design software, the model is then prepared for 3D printing using a software we call a slicer. And this slicer translates the model you get from your 3D design software into a format that the printer can work with. So once that's done, it's taken to the printer to be printed. And once that is done, you have now officially brought your idea to life. So what you had initially in your mind, or maybe you do it on paper, you said, okay, I want to build this. It's not available on the market. It's something that is unique. I need to bring it to reality immediately. 3D printing has helped you to do it. So if you're printed what you've printed, even if it doesn't exactly match what you've designed or what you had in mind, that's the beauty of 3D design. You can go back to the software, edit it, redesign it, and reprint it. So that's the beauty of 3D design software. That's the beauty of 3D printing. So you can just quickly test your ideas, print it, and make it a reality as soon as possible, and keep iterating on that. I'll be showing you this workflow in a pre-recorded demo session. I'm making a simple name tag that I can attach to a key ring. So before that, I'm showing some examples here of 3D printing applications in STEM. For example, now you can see um, some plant models, some geometric models. So teachers can use this 3D design software and 3D printing to create models to better help their students understand what they are being taught. So they are moving away from, okay, the textbook just says this, or this is what the note says. They're moving away from that and allowing their students to visualize what these textbooks, what these tutorials, these notes say, and help them understand what they are being taught. And likewise, the students aren't limited to just interactive model. They can also explore the concepts that they are being taught. with 3D design software if they are appropriately taught. So they can explore this concept with physical models, and this enhances their learning process. It also helps them build skills like critical thinking, problem solving. It helps them to reconcile ideas with reality. So in a few moments, I'll be showing you the demo. I'm using Tinkercad. It's a pre-recorded demo. I've sped it up a bit so that we can maximize time. So it's a pre-recorded demo session. I'm using Tinkercad, like I mentioned earlier, for the design, and Orca FlashForge as my slicing software. And we'll be printing on the FlashForge 85X printer. Now you'll see a video of that once we are done with the demo. You see it live printing from our office right here. Now, you don't always have to design from scratch. It's not a must. There are plenty of models you can download online. I'm sure some of you already know that. So if you want to use something as a teaching aid for your students, you don't have to design it exclusively. But in the context of what we're discussing today, that is helping students advance in their learning, helping students advance so that they can take control of what they are learning. Designing their models themselves is what really fosters that creative thinking and boosts problem solving skills. Okay, so this here we are right now in the Tinkercad. Please let me know if you can see the demo clearly. You can just raise your hand or give me a reaction if you can see the demo. Hello? In any case, I'll just
Yeah.
continue on. So yeah, I'm starting in the Tinkercad workspace. So like I said, I'm creating a simple name tag, which I'll be attaching to a keyring. So the first thing I'm starting with here is a cylinder. Now, Tinkercad is very good for as a starting point for students to begin in 3D design because it's built on basic logic that we bring um, simple objects, simple shapes, and combine it together to create more complex shapes, more complex 3D objects. Either by moving, you can resize it, you can cut, combine these basic shapes to create these complex shapes. So the first thing I'm doing here is creating a hole for the keyring. I'm doing that by dragging the cylinder to the work plane, resizing it to the dimensions I want, right? And I'll be creating a hole within it. Then for the base of the key of the name tag, I'll be using a box, right? I'll resize it to the height I want. Then I'll be creating a notch in it so that I'll be able to join these two shapes together. So, like I said, Tinkercad is a very good starting point because it's quite simple, but there are limitations, right? So one of the limitations now is that there are tools that they are just very basic tools. You can allow it to add also or subtract from a shape, but that's the limit of where it is. But that doesn't stop you from actually creating more shapes, right? This is where design thinking comes in. So right now, what I did was that I used two cylinders, or they're called, you can say two circular objects, to subtract from the objects I placed initially on the work plane. And this was to allow me to create exactly what I want. A rectangular name tag with a hole for a keyring. So I first made a donut shape. I then made a notch with the box shape. Then I combined it together. Now, students, if faced with this type of problem, will be forced to adapt. Sorry, will be forced to adapt to that problem that just arose, right? You're forced to think, okay, how can I create this shape? It's not available in Tinkercad's workspace. It's not available there. So how can I bring the shape that I have in my mind to reality? So that's where design thinking comes in. They have to think through the process. They have to okay, I have what I have and I have these tools. How would I combine it to get what I want? So that's where design thinking comes in. So now that I've made the base of my name tag, what I want to do now is that me personally, I don't like my designs to have sharp edges or sharp corners. So what I'm trying to do now is create rounded corners for the name tag. And like I said before, there are limitations, right? But that doesn't stop you from doing exactly what you want to do. So now there's no tool here to bring these rounded corners into my design. Fusion 360 can do that for you, right? But Tinkercad, like I said, is a beginner software. So once you've realized that, you now have to think, okay, what next can I do to bring this feature that I want into my design? So that's what I did right here. If you saw, I brought a box to the work plane, used a cylinder to cut out the shape I want, with some other box to cut out the shape I want. I used that to cut out the rounded corners on my name tag. So once I scaled it down I reduced the size to what I want, I just moved it in place so that I could cut out the sections that I don't need. So once that is done, I can now make my name tag perfectly with rounded corners, and I'm now satisfied what I get. So the next step in this process, after making a name tag, the base name tag, is to add text. Obviously, it's a name tag. So right now, I'm typing in my name, Paul, right? And I'm sending it to a format that I'm satisfied with, right? So I'm going to reduce the size a bit, the height of the text a bit, so that it's a bit flush with the name tag. It's closer to what I want. And now I've changed the color of the text so that it matches exactly what I want. Now I'm done with my design. As you can see, just from a few basic shapes, I have now created a name tag. So this sort of workflow now is what you want your students to engage in. Once that was done, I exported my name tag into a file that I'll be translating to this license software. So what you see here right now is this license software. This license software basically is the bridge between your 3D model, that's the 3D object you created, and the 3D printer. So what it does is that it specifies to the printer how exactly you want your object to be printed or how exactly you want it to come out. So it uses a set of predefined settings, and it's such that you can tweak these settings to control how much filaments your printer uses, how much material it uses, how much time it will take. And that is what I've done with this now. I've configured it so that it will print in about 4 minutes or so, nearly 5 minutes. So once that was done and I was satisfied with the time, exporting it as a G-code file, which is the native file format that 3D printers can read. And once I've done exporting, I can now send that G-code file either over the internet, because fast 3D printers have that functionality, or by flash drive. I can send it to the printer to print my object. So now I'll be handing over to my colleague, Mr. Chukwemeka, to show us the demo of the 3D printer in action. We're printing the name tag right here in our office.
Okay, please, if you have a question, this is not the time for question and answer, but from what we've said so far, if you have any question, kindly indicate by raise of hand. I will unmute you and then you can speak. If you're in a place where you cannot speak, kindly use um, the chat option or the Q&A option. So you can type in your question, I will read it out and we'll answer your question. This is so we can maximize time and make every bit of the time we spend here count, instead of just having a dead air.
Yeah, good afternoon.
Yes, good afternoon.
Yes, my name is Raouf from Heritage Global Academy. Um, so, thank you very much for the opportunity that you have giving us an orientation as regards how to set up a STEM lab and especially how to use a 3D printer in our school to aid learning. So, for the software that we are using, is it readily available online to be downloaded, or their paid version, or how do we go about these softwares? And obviously, this training is for one to be able to use this properly. I believe there will still be more training maybe after now to equip educators properly. So, how do you usually have access to these softwares? Are they readily available online? Thank you.
Okay, thank you so much. Do you want to respond to that, Paul, or do I respond to that?
Yeah, all right. I will. So, Mr. Ali, thank you for your question. Yes, the software, um, like I said, these two software that I mentioned earlier, Tinkercad and Autodesk Fusion, are from the same company, Autodesk. But like I said, Tinkercad is more geared towards beginners in design and students. So that is available online for free. Just type in tinkercad.com in your web browser. But for Autodesk Fusion, it's more geared to more advanced design capabilities. So it's not, you can get it for free. You can get a free version, but there are limits to what you can do with the free version. But even if you have the free version, you can still learn with it. But it will just be limited in the amount of features you can access to uh, create what you want to create. So I hope that answers your question.
Yeah, thank you very much.
Okay, thank you so much. Let's go over to the demo session right now so we can have a talk through because the bed is already leveling and we don't know what that is. So, Chukwemeka, please, can you speak through the demo session? We can see your screen.
Miss Linda, I'll be taking over from here. So right now the printer is preparing to print the name tag. So what it's doing right now is it's heating up the extruder. The extruder is what the printer uses to melt the plastic, right? This plastic is the type that can be melted. It's going to use it to melt the plastic so that it will be able to flow in the shape that we want to print our object in. So right now it's preparing to heat up the filament to the right temperature to print. So that's what it's doing now. So once it's gotten to the right temperature, right, it's going to start printing. So these are some few things you can't really avoid with a 3D printer, even though yes, it's going to complete from the start of printing, it's going to complete in 4 minutes. But all these set little startup sequences are necessary because it can't just start code. So that's what it's doing right now. It's getting ready to print. And now, Mr. Ali, there's another thing I want to add to my response to your question. So for schools, right, um, they can partner with us and we can seek to get from Autodesk, that's the parent company of this software that I was talking about, to get free licenses for them. So Autodesk does something very wonderful for students, which is that they provide free um, access to their software, their advanced software, at least some levels of the advanced software for students for free, because they understand that in order for students or for professionals to be able to build or to use the software that they are making, they have to start from somewhere. They can't expect them to just jump into the industry and start you can't expect all students to just jump into the industry and start learning from there. So they allow students to have free access to the software. So you can reach out to us and you can be able to get Autodesk to provide free educational licenses for your schools. I think if you get me, just let me know if that's clear.
Yeah, it's very clear. Thank you for the addition.
So right now the printer has started the first segment of the printing process. So what it's doing now is just it's extruding a bit of filament to just clean the nozzle so that it doesn't end up messing up your actual print. These are what some of the features that modern printers come with so that your print quality comes out as best as you set it up in your slicing software. Yes, sir. Sorry for that session. So back to what I was saying. Um, once you've started, once I started printing it, yeah, you can see it moving to the position to start. Now, one thing I need to mention about this 85X, as you can see, it has these cylinders on the side. They are what we call filaments. These colored cylinders on the side, what we call filaments. That's raw material for our 3D printing. Now, one thing to note about this printer, the 85X, right, is that it allows uh, more than one material. Normal 3D printers offered by Flashforge usually allow just one material to print your object, but the 85X allows more than one material. It can allow up to four materials to print your model. So the reason why I'm using it for today's demo is that if you notice, the name tag had two colors, right? White and orange. Now, on a normal 3D printer, the process to start printing your like two colors, right, is a bit tedious because you have to start pausing, changing the filament from where you started. Then you have to change the filament to start printing. You have to start printing from where you stopped. It's a bit, it halts the process, stops the flow, and it's a bit slower than just using this printer. What this printer does is that it automatically does the whole process for you. So it incorporates into its G code from your slicing software. You select the printer, right, as a process, and incorporates in the G code that the printer will use to print. Incorporates all these sequences that will allow it to change the filament without you having to stop the printing process. So there's no loss in time. There's no, you don't have to waste your time going back to it. It does it automatically for you. So that's why I decided I will be using this printer to print the printer. It's not that you can't print multicolor or multi-material. That is more than one material. So for this example now, we are using a material called PLA. It's not that you can't print more than one material with other printers, but like I said, it's a bit tedious. You would have to pause. You'd have to remove the previous material, put in the other material, then continue from there. And it won't work for objects where um, the difference or the divide between colors is not as linear or it's not as specified as just up and down. For something like our name tag now, it's quite simple. One layer is white, the next layer turns orange. That's quite simple. But when you have something where on a single layer you have both white and orange, it's not going to work the way you think it's not going to work at just, oh, I'm going to pause, I'm going to remove this filament. When it gets to the time you need to print white, I'll now put it, it's not going to work like that. It's not going to be easy at all. If you want to do that, it's more or less like you're extending the time of printing so far that it's no more practical. And that's why you get something like this. So this is the reason why this printer is quite essential to this particular process. So apart from having the fact that you can print more than one color or more than one material, right? It saves time. Instead of you wasting time trying to set up yeah, it does it automatically for you. So it's quite all right for multicolor or multi-material prints. It also works for when you have there are things we call supports in 3D printing. I don't want to get too technical, but there are things we call supports so that it allows your print to, in quotes, print on air by using another material under it, right? And let's say, for example, now you don't want the material that's under it to mess up the look of what you're printing. You don't want the support to mess up the look. So it can come with, there are dissolvable supports where you can put the full print in water. The support material just dissolves, right? And what you're left with is a clean model, clean object. That's the benefit also of this 85X. So now, as you can see, the printer has already started printing the first layer, the white layer, the base, that's before text. So it's already gotten the major shape down. So what it does is that it just keeps layering on this shape until it reaches the height we set it in our 3D design software. So once it reaches that height, it sets the text just immediately after this white layer. So once it reaches that height, it's going to change and it's going to print that orange layer of text on top of it. If there are any questions you have concerning what's going on, feel free to unmute your mic or feel free to just raise up your hand and we'll unmute your mic. I think you have any question. Yes. Can anybody see the video?
Yes, we can see it.
Sorry, Mr. Ali, I'm coming to you.
Engineer Ejiro. Okay. Sorry, Paul.
Yeah.
Sorry, Paul. Engineer Ejiro, it seems like you can't see the video, but Paul, Ali, I'm sorry, Mr. Ali, you can see the video, right?
Yes, I can see it.
Okay, who else can see the video? Because I can see the video and I'm not in the location where they are doing the printing. So please, sir, can you leave and join back? It's one of the technical issues we must have highlighted in the beginning. If you can just quickly leave and join back, it should be fine. Okay, your hand is raised. Please go on.
Yes, thank you. I just want to also ask, because looking at this, I'm looking at it that if I'm to produce or print a more sophisticated material, not too sophisticated, is there a need to learn something about orthographic drawing? Yes, I know that maybe for someone that does not know anything about it before, we might just still limit ourselves to very simple printing. But for whatever reason or for extended knowledge, is there a need to learn orthographic drawing so that you can see maybe the different faces and all that? That's number one. Number two question is that, please, I hope you got my first question.
Yes, Mr. Ali, I got your question.
Okay,
So,
yeah, the second, okay,
okay, please let me answer your first question. So,
okay.
if you want to produce more sophisticated models, there is a need to learn orthographic drawing. Now, the reason was that orthographic drawing is like, I'm sure some of you already have like a basic knowledge of, let's say, technical drawing, but for those of you that don't know, it's more or less like you're presenting a physical, a 3D object in views, side, right, top. So it's more easy to understand or replicate elsewhere. Now, that's why I said there's a need for more sophisticated models. So like you saw in Tinkercad, I was just manipulating shapes. It just boxes, just cylinders. These shapes were already predefined. I didn't need to create them or I didn't need to make them or anything. But if you wanted to create a more sophisticated shape, now I'll be showing you some models after this demo is done. If you want to create some more sophisticated shapes, you would have to learn at least a bit of technical drawing or went your mind to the technical drawing or orthographic drawing process, because it's like the fundamentals of sophisticated design or sophisticated drawing. You don't need to learn it to 3D print. You don't need to, but if you want to get a higher level of sophistication, yes, you do need to learn it. And that is something that if you are joining us in one of our training courses, we can have as a beginner course or a beginner refresher. You can have that explained, you can have that expatiated on. So that's what this other software, like I mentioned, Fusion 360, Autodesk Fusion. Like I said, it's more than Tinkercad. Tinkercad is targeted at beginners, very simple to interact with. But Fusion allows you to create more sophisticated models. Okay, I hope that answers your question.
Yeah, that's fine. That's fine. Thank you. The second one is for the filament. I can say that we have. You called it. So you called the name. You said the material being used. You said the name a few minutes ago. But I didn't get that. So maybe in a video that I've watched online, I see people try to convert different materials, maybe plastic. You try to convert different things to something like this, and they do print with it. So can this machine, or is there an opportunity to do that, or those videos that we see online are not totally true? Because I want to believe that maybe one of the ways to also manage your resources or to be indigenous is to convert all of those things that seem to be a waste into your raw material. So is this also applicable here? Thank you.
Oh, oh yes, it is applicable. So the thing about it is, it's a problem of understanding what material you're using to print. So I'm assuming the ones you've seen online are those videos you've seen, like converting plastic bottles to 3D filaments or something along those lines, right? I'm assuming that's what you've seen. So it's you can use that to print. But like I said, each material, the one I mentioned earlier, is called PLA, right? Each material has different characteristics, and you have to consider those characteristics when you're printing. Now, some printers might not be able to melt the material that you're trying to use. I'm not saying that it's all printers. Some printers might not be able to do it, right? And some printers might not just be fit with the capacity to melt that material that you're trying to convert. PET, what used for most plastic bottles, can be printed by modern 3D printers. So that's possible. And you can also convert your 3D printing waste. Let's say you're trying to, because sometimes when the printer starts, it extrudes a bit of material so that it doesn't clog up the nozzle. So you can convert those wastes, right? With there's something called a recycler, 3D filament or 3D printing recycler. It just converts those waste to 3D printing filament. I hope that answers your question.
Yes, that's correct. That's correct. I believe there's still more to learn, and we are very much open to that.
Okay, that's wonderful. So our print has finished. Um, our print has finished. Mr. Chukwemeka will be helping us show. Oh, you're seeing another one of our projects ongoing. As that is but we'll soon show you the finished name tag. I hope everyone can see. Can we all see the finished name tag?
Yes,
You can
yes.
just raise up your hand, or if you're not seeing, just let us know. Hello? Oh well, we can always show that later, but I saw something in the queue and okay, thank you. Thank you. So like that, it's as based on the printer, the slicing settings I set. right? I optimize it for speed, so the quality might not be as to the point I saw on my digital the screen, right? But I know what I wanted, and I'm satisfied with the fact that I could print it in 4 minutes. So it's all about balancing your requirements or balancing a few considerations, whether you want to print faster, right, or reduce in quality, or print slower and increase the quality. So that's that. No. So the model behind is something that we well, an initiative was started in the organization. So we are working on premium lighting, just a snapshot or sneak peek of what we're doing. So working on premium lighting that incorporates ideas from nature, from abstract concepts into lighting. For example, now this one is incorporating an onion board or an onion into design. I don't know if you can see the fine details or fine uh, the surface of it, but you can see some lines in it that somewhat mimic an onion surface. Right? So that's just one of the other things we're um, getting into AI generative cloud services. And I think I saw a question from Engineer John. Engineer John, just put your question in the Q&A. We'll be able to get back to you by the end of this demo session. I just want to quickly show some of the other works we have here in the office. Chachika will be helping us with that. Please confirm if we can see.
Yes, yes, they are visible.
So these are some of the examples of what we have done here. So this is a 3D printed airplane model, right? Obviously, this is for demonstrative purposes. As you can see, it can more or less transfer the features of, let's say you want to print an Airbus or a Boeing, you can do that with 3D printing. Some of the other things we have engaged into, um, 3D printed models for classrooms. For example, this is an animal cell for use in biology, right? I've done bases, lamps, some other projects I've done include enclosures, for electronic components. Yes, this is a part that we did also for biological demonstration. So these are some of the things you can do with 3D printing. Very, very, very expansive, very flexible technology. You can print what you need to print quickly, faster than what you do with normal manufacturing methods, where you have to go and, let's say, meet somebody, pay a lot of money to set up if like the manufacturing process just to produce it. You can't do that for just a few parts or few objects. So that's the beauty of 3D printing. All right. So thank you, Mr. Chukwemeka. I think that's okay.
Okay.
Remember, you guys, if you have any question, you can
We have a
put in
question
the
in
Q.
the There are some questions in the Q&A. Can you please answer them so we can move ahead? We really have a few minutes left.
Just give me a minute.
Okay.
Question. Questions on
Okay. You can read out the questions, then you answer. Should I
okay
help you read
from
it
engineer.
out?
Oh, I can see them already.
Okay.
So from engineer, if there's a fault with the display of the printer, can it be fixed? Our Creality printer has an issue with the display. Display has been replaced, but still nothing. And without display, we can't operate the printer. Okay, yes, it can be fixed, but we can't just say yes without having to fully troubleshoot the printer, we'll have to get it to. You can send it to us. We also do repairs. We also do troubleshooting of printers. You have to get it into the hands of technical people to figure out what exactly is wrong. Because you said you have replaced the display, right? And still nothing. So there might be something more that's wrong with printer. You have to bring it to more technical people, the technical side. Like us, we handle repairs too, because we are distributors of plasma 3D printers in West Africa. So distributors. So you can bring it to us and we can help you with that. Now, Mr.
I need to add something to that.
Yes.
Okay, yeah. I think Mr. Engineer John actually also wants to know if the printers that we have, if we can fix it, if he has an issue with the display. And he now additionally let us know what is going on with the cruelty. Engineer John. Up. Okay. Okay. So she wants us to know. So she wants to know if the display can be if the display can be fixed. Yes, the display of the 3D printers we have, the FlashForge 3D printers can be fixed. Okay. And that is one thing that we are enjoying as partners with FlashForge. If the fault is manufacturers a manufacturing issue, like maybe if by any chance it just stops displaying, they if it wasn't like tampered with, it's just funny enough, it's just some technical matches that will be done and it will be corrected. My point exactly is that we'll have to speak with the manufacturers and they'll simply let us know, press here, press there, and press there, and the display will be, fixed without even having to change. Most displays, especially FlashForge, is not even that the displays are bad. It's just simply that you just need to press one or two things. We've not really had any issue where the screen or display had issues. It's basically something that you have to touch up somewhere and just fixes it. So yes, we have parts available, either the nozzles, the displays, and any other part of the 3D printer is readily available in our office. And that is what we also gain as being partners with FlashForge. Okay, Paul, please. There's another question. Paul, you're muted. You are unmuted.
Okay. Can you hear me now?
Yes.
Okay. Get into the next. Miss Linda, if you can read it out to me.
My question is, so this question is from Elijah. So my question, can I also design models using other CAD software like AutoCAD, SolidWorks? Can the 3D printer still print it?
Yes. So with other software like SolidWorks, AutoCAD, you can design and print. One thing though with AutoCAD is that it's mostly optimized for 2D drawings. That is like your orthographic drawing, like Mr. Ali mentioned earlier. 3D drawings, your technical drawings, mostly optimized for that. It can do a bit of 3D modeling, but that's not what I would suggest. Now, AutoCAD is from Autodesk. You can work with their other software like Fusion, Autodesk Fusion, even TinkerCAD to design models. I'd advise that instead of using AutoCAD, but you can also use SolidWorks too. You're not limited. That's the thing. You're not limited to just one software. Uh, almost all 3D or rather 3D design software can, or CAD software can create models that you can 3D print with. So SolidWorks, there's no limits to it. We're even partners of SolidWorks too. That's all systems. We provide SolidWorks for organizations, provide training too for SolidWorks. So you can use almost any CAD software, generally, or to 3D print. So there's no limitation to it. We just highlighted Autodesk Fusion and Tinkercad because those are the ones we recommend for students starting out in learning 3D design. So they move from Tinkercad, then they move to Fusion 360. And if you want to, let's say, advance a bit higher, you can start considering things like SolidWorks. It's not like SolidWorks is not, or Fusion is not as good as SolidWorks, or all these software are not as good as each other, but each one has specific tools that, it's a business, it's competition. Each one has tools that puts each one higher than the other. So that's just it. You can use other CAD software to design. Yeah. I hope that answers your question.
Yes. Oh, sorry. Does that answer your question? I don't know if the person that asked the question is still here, but the person has a follow-up question that said, how fine is the surface finish going to be? Would there be need for finishing after the
Okay.
print?
Okay, that depends now on, remember what I said, there's a software called slicing software, right? And this configures your 3D printer to print what you've designed. So you can control the settings in your slicing software to print it as fine as possible. But what that does is that it adds time on top of it. So you can either do that and to take a longer amount of time. You can print it so that it prints in the tinier layers. That's what it does. If you want a final finish, the basic thing you can do is just print it with thinner layers. So let's say for the ones that I printed today, I used a layer height of 0.2. You can also print it much smaller than 0.2. You have to go to 0.08, 0.1, right? So it does depends on how much time you want to use. Or you can print it at that 0.2, then you do what we call post-processing, right? Post-processing is basically uh, actions that you do just to improve the surface finish a bit, like uh, sanding, polishing, right? You use what do you call it? Sandpaper to increase the finish of the parts. So it's something you can do if your original part is not as fine as you'd like it to be, or the finish is not to the point that you want to be. You can also post-process once you're done creating or done printing your model.
Okay. Moving ahead, I also have a follow-up question from, hold on, I think I've just moved past it. I have a follow-up question from Engineer John about saying, I don't think it's a display problem because we have replaced it but still not displaying. Um,
Uh,
she's talking about the display.
okay. Like I said, Engineer John, like I said, you might have to bring it over to us to troubleshoot what exactly is going on with it. You've said you've replaced the display and it's not working. It has to undergo more troubleshooting. If its display has been replaced and it's still not working, it has to undergo more troubleshooting. So I see from the Q&A, you say you're based in Port Harcourt.
We can have the conversation. Are you there? Are you saying something? You can have the conversation out. Okay. Let me try to let me unmute. Apologies. Anybody in this call can actually unmute to speak right now. Okay. Okay, so let's move ahead so we can round things up. Before we finish up, we would share our contacts on how you can contact us so we can have the conversation. away from this call. Someone is raising, please hold on. Please, okay, let's have you say something. Please let it be actually brief because we are overshooting the time we are allotted for this webinar. Please go ahead, Felix.
Okay. So I think from my experience working with generative CAD, I think there's something very peculiar that some of us who also run schools and have STEM clubs or STEM academies don't get to understand, especially in the procurement process, is local support. And this is where I think generative CAD also provides, in a significant point, because if that printer was processed through us and it was a flash file processed through us, that particular problem, what if even when it's beyond warranty and you have issues, what you just need to just send it to us, and then we just troubleshoot, get you a reputation, solve the issues, get the parts. We have spare parts for our machines here, and we're able to replace that. Anyone that we think that that wouldn't be the team here can handle generative card. They send out to the partner directly, the manufacturer, and then they can get the support they need to be able to attend to the printer, unless the printer is totally bad. But I think that's also one particular thing, especially for businesses, that leveraging that technology support, local technology support, and supply chain and all that. I think it's also one critical thing that I personally have experienced. So, but again, with your own printer, I think what could be is you mentioned about not having, replacing the screen. So basically going to be either a motherboard problem or a flex problem or probably something there, but the team can't really know what exactly it is until you have to start and do some troubleshooting, again. But probably maybe you can connect to the team beyond beyond the class and then beyond this section, and then you can take it off from there. Just my contribution. Thank you.
Thank you. Okay, let's move ahead to the moment that we all be waiting for. I hope we all be waiting for it because I'm excited to share. So we have a digital manufacturing grant available. Precisely, we have 4 digital manufacturing grants available to attendees of this webinar. People that are still on this call, and maybe people that are on this call, and then people that joined earlier. But so far as you attended this webinar, you are qualified to be part of this manufacturing grant. So we have, I don't know how many of us saw the Adventurer 5M 3D printer that was printing our lamps. That's white stuff that looked like a plate. Yeah, but that's actually a lampstand. So yes, we are giving out 4 of Flashboard Adventurer 5M 3D printers to schools, primary, secondary schools, right? And so it's a donation. Okay, it's a sort of donation. So we are donating that kind of printer, brand new, never been used, to 4 schools. And we are not just donating that printer, we are also giving you a curriculum that has teachers and student resources, because most of us do not have the skill set. So you need a curriculum to guide you as to what to teach your students. And even what's in particular about this curriculum, it has projects. It's very simplified, okay? And we're also having a 1-day, 3 hours free workshop on how to use the curriculum, applications of the designs and 3D printing for classrooms and for work. So there are applications in this curriculum. So you can't just hand you the curriculum without letting you know how to use it. So we're going to have that 1-day, 3 hours free workshop. It's going to be a virtual workshop, okay? Because we understand that a lot of us are in different parts of the country, and we don't want to make distance be a limiting factor, okay? And so we're also giving you a 1 kg filament. I don't know if you remember that orange stuff beside the printer and the white stuff. So those things are called filaments. That are the raw materials that will now go into the printer and melt and now form the shape of whatever you have designed and given it. So we are giving just 1 kg, and then you can get as many as you want. Okay. All right. However, you need to qualify for this free donation. So for you to qualify to get everything I've just mentioned, you have to purchase an Adventurer 5M Pro. So it's a sort of buy one, get one free, but you're not just getting one free, you're getting a lot of things. And just like someone mentioned in this call, if you what distinguishes us from just getting on Amazon or getting on any other of this platform is that you actually know the people that you are working with. They are there to support you. And if it's something that is not within what we can do, we take it up to our partners, Flashforge, and they help you sort it out because they made it, so they should know the cheat code, right? So you have to purchase the Adventurer 5M Pro, which is at the rate of 1.7 million naira. And then you'll be able to get the Adventurer 5M Pro, the curriculum, the walkthrough through the curriculum, and a free 1 kg filament. And then to even maximize what we are giving you, to even giving you more offer, we're going to be shouting you out on our social media platforms. Our LinkedIn has a very strong base. So especially on our LinkedIn, but all of our social media platforms are going to be highlighting your school or your STEM club or robotics club as one of the leading partners one of the leading institutions who are trying to forge through the future of learning, who are trying to, break away from the old system of learning. So our marketing team are going to carve a way to tell your story on our social media, and you might even, as well as even promote it, do an ad around it on our Meta, that's Facebook and Instagram. So yes, these are all you stand to gain and qualify. And this is on a first come, first serve basis. Trust me, once we've maxed out the 4 numbers, there's nothing else we can do, because this conversation did not just start today. This conversation started last year. And for us to agree at a particular number is not just something someone just wishfully thought about. And so you can contact us away from this webinar. We have a location. Currently, we are moving. We are moving from our current location to another location. That's why there are 2 locations on your screen. We are currently at Sally Close. That's where we are making this call from, having this webinar from our office in Sally Close, 3 Sally Close off of Debi Street, Haruna bus stop in Oba. Oba is in Lagos State. And so, but we are moving from next 2 weeks, Monday. You shouldn't come to Stanley Close anymore. Come to our current location, our new location, 26 Akinwale Street off Eyabato Street in Ogba. Ogba is still in Lagos mainland to be precise. And I don't know how many of us had a reminder from our WhatsApp team. So yes, this is our number. It's our call number. It's our WhatsApp number. It's our official number. So irrespective of the person in the office, in the company, this number is permanent. Also, it will always be here for us to reach us through. Okay, our website is not here, but it's www.generativecad.com. Generativecad.com. Just what you can see here, generativecad.com. And then if you go down, you can see our social media icons. Just click on Instagram, LinkedIn, whatever, you take it to our social media platforms, and you can, read up anything you want to read up. So away from this webinar, kindly contact us. And also we'll be contacting everybody that has taken part of this webinar this evening or this afternoon to actually hear your peculiar case. Some of us have mentioned it here, but away from here, we'll actually spend more time with you to have a conversation with you. So please save this number on your phone. So whenever you see this number, you know that it's from Generative Card, because trust me, we're not going to call you with any other number but this number, okay? So yes, thank you so much for your time. And we really appreciate. I'm not going to be ending this call because I think I saw some things in the chat. I'm just going to stop sharing We're going to take a few minutes to look at the chart once again and see if there is anything that needs our attention. I'm looking through the charts. Okay, I think everything has been answered. Can individual also partner with the company to set up a mini toy company? Yes, you can partner with us to set up a mini toy company. We have to have that conversation away from this call. Do you have an office in Port Harcourt? No. We have a base in Owerri, which is close to Port Harcourt. We have our team, our business, a few business and marketing team members in Owerri. So I feel like we can have this conversation out of this webinar. But we have a local branch in Owerri, and then we are in Lagos currently. Someone said, in a situation after designing a model, can it be sent to you for printing in proximity in cases where we don't have access to the printer? Obviously, yes. We are a 3D. So part of what we do is also 3D. Part of also what we do is 3D printing services. If you go on our website, there is a part where people that already designed something can upload their design. We print it and we send it to you. You don't even have to interface with us. But in this situation, I don't know if you are okay. You said after designing. Obviously, yes. Just upload your STL file on that. Please, Paul, can you get the link and put it in the chat? Is it possible to do that right now? The website card where they can just go and upload their STL file.
Yes, Mr. It's possible. Give me a minute.
Okay. Yeah, so once you get that link, upload your STL file. It will give you a breakdown. So you don't even need to interface with us. We've made everything very simple because we are hands-on. We are very busy, not be too busy for you, but we've made everything so easy that if you upload your STL file there, upload the kind of filament you want, the everything how you want it, the dimensions, the thickness, however you want it, the color you want, the kind of filament you want, put it there, the size you want, and you send it. Once you send it, it will take less than 20 seconds to give you your cost there. And once you see the cost and it's okay by you, you make your payments. Once we receive it over here, we would print it for you and send it to you. However, if you want to see it and then you want to contact us on our WhatsApp chat, you are still free. However you want to do it, it will still get to us regardless. It's going to simply let you in on. So this is, I don't know if you can see my screen. So I just clicked on the link right now. So this is it. You log in, you upload your card file, you get an instant quote, we print and we deliver to you. You get to choose the kind of materials you want. And then we also sell filaments as well. If you want to get filaments, we also have a lot of filaments available. All right, thank you so much for your time. We really appreciate your time here, for having, sticking with us to the end. We really, really appreciate your time, and we do not take it for granted. We understand you have a lot of things in your schedule, but you took out time to be with us here today. We do not take it for granted. Thank you so much. I hope the webinar has been worthwhile. Thank you so much, and happy weekend. Thank you so much. Thank you, everyone. Thank you.